So welcome back. In this video, like I said in the last video, and I really meant it, that we're going to learn how to find the center of rotation. So just like when we were doing reflection, we learned how to reflect the object, but in some cases we were given the object and we were given the image and we were asked to find the line of reflection. Just like that over here also, we're going to be given the object and we're going to be given the image. We will be asked to find the center of rotation. Not just the center, we will be asked to define what transformation maps A onto B, okay? So right now, since we know it's rotation, obviously the answer to that will always be rotation, but once we're done with the whole topic, then we will first have to narrow down what transformation it is. Then of course, depending on the transformation, we'll have to describe that transformation. So yeah, that's that. Okay, so there are basically two types of rotation, okay, two types of two different angles, you could say, that we're going to be coming across. So one is 90 degrees. So for 90 degrees, to keep it short, what we do is we make a perpendicular bisector. Now I will show this to you with the help of an example. Okay, we make a perpendicular bisector, and with 180 degrees, what we do is we join the object and image. Okay, now this is just like a really summarized version of what we do. Okay, it's not as simple. Okay, in fact, if you think it's that simple, I'm afraid I have bad news for you. For 180 degrees, yeah, let me tell you, for 180 degrees it's extremely simple, but for 90 degrees it can get pretty complex. Okay, so we have over here an example which says describe fully the single transformation that maps triangle A onto triangle B. Now it's, since after the word onto we have B, it's understood that B has to be our image, okay, and A has to be our object. Now notice how it's over here it says single transformation. So like I said earlier, that we will have to write down three things, not necessarily three, but yeah, we will have to write down first what transformation it is. Now right now we've only done two. We've done reflection and rotation, so obviously it's not reflection. By the way, reflection and rotation are the two most confused transformations, you could say, that they're basically the two transformations between which distinguishing can be very difficult. So I have a dedicated video for that, which I will make later on, so don't worry about that. But over here we will first have to write down the transformation, and then depending on the transformation, which right now we know it's rotation, we will have to define that transformation. So since this is rotation, that means we'll have to write down the center and of course the angle of rotation. As we know that these are the two things, angle and direction in fact. So these are basically the three things that define rotation. All right, center, angle and direction. So a couple of things that we can immediately point out is that since A is being transformed onto B, and you could see that this line was initially vertical, it has now turned horizontal, so it's a no-brainer that it has been rotated 90 degrees, and you can see that this is the direction in which the image has ended up. So that means it's going to be 90 degree anti-clockwise. So this is something that we can point out straight off the bat. Okay, however, finding the center is something that's challenging. Okay, so for that we make a perpendicular bisector. Now there are two ways through which you can make a perpendicular bisector. One is of course the ruler and compass method, okay, which I can't do right now, but I will make a video on that also. But the other is by using the coordinates, the midpoint and all of that. Okay, now that can be, like I said, complex, so I want you guys to pay close attention. Okay, and don't lose track, don't lose your focus. If you do, then feel free to rewind the video. Okay, but yeah, make sure to fully understand before you attempt a question on your own. Okay, so the first thing you want to do is you want to label the points and their images. So let's say that this is P, Q, R. Okay, so that means after rotation, point Q is the 90 degree point, so this has to be Q prime, okay, and this has to be P prime, and this has to be R prime. Okay, now the first thing we do is, so basically we need two perpendicular bisectors, and then we need to see where they're intersecting. So the first thing I need to do is I need to decide which points, what perpendicular bisector am I going to draw, or which two points the perpendicular bisector am I going to draw. So let's say I draw a perpendicular bisector of let's say R and R prime. Okay, now there's no restriction as to what points to use, you can use whatever point you want, but let's say I decide that I'm going to draw the perpendicular bisector of R and R prime. Now first thing you want to do is you want to find out the midpoint. Okay, so find the midpoint of R and R prime. Okay, so R has coordinates 6, 4. Okay, R prime has coordinates -3, 3. Okay, so let's find out their midpoint. So finding midpoint means just adding them up and dividing them by 2. So if I add them up, minus 6 plus minus 3 is going to be 3 over 2. And then the y coordinate, 4 plus 3 is 7, 7 over 2. So that means 3 over 2 and 7 over 2, which means 1.5 and 3.5. Okay. So 1.5 and 3.5 has to be somewhere over here. Okay, you can see that I've made an X over here. Now from this point, here's what I need to do. I need to rotate R or R prime, doesn't matter, 90 degree clockwise or 90 degree anti-clockwise. Okay. And yes, you have the liberty of that. Okay, I know initially it's hard to wrap your head around it, that really we can do either, and we can do 90 degree clockwise or anti-clockwise. Yes, that's the case. So let's say that I take R, okay, so basically what I'm doing is I'm taking this point as my center. Okay, so this point is now my center. Okay, so I'll just call it C. And using this as my center, I'm either going to rotate R or R prime. Like I said, it doesn't matter, either 90 degree clockwise or 90 degree anti-clockwise. Okay, so let's say I rotate R 90 degree anti-clockwise. Okay, so you can see that this is, okay, let's count the number of units. Where is my assistive touch? Here it is. So half, 1, 2, 3, and 4. So 4.5 units to the right and half unit up. Okay, let's do that again. 4.5 units to the right and half unit up. So let's take this if I rotate this 90 degree anti-clockwise, that means taking it 4.5 units up and half unit to the left. So let's do that. Half, 1, 2, 3, 4, and 1 unit to the left. So that means this is where we're at. Let's do that again. Half, 1, 2, 3, 4, and half unit to the left. So what we now have are basically 2 points that we can now join and make a perpendicular bisector. So this point, believe it or not, is basically the perpendicular bisector of R and R prime, which, like I said, you could have done this with the help of a compass also. Okay, but the problem with using a compass is that it's not always as accurate. If you mess up your arcs, then things can get pretty, not ugly, but basically it's not going to be as accurate as it is when you use this method. Okay, so we did this with R and R prime. Now we're going to do the exact same thing with P and P prime. Okay, so basically just another set of object and image. So for that, let me switch to a completely unique color. Let's switch to purple. So here's what I'm doing. Find the midpoint of P and P prime. Okay, so P has coordinates 2, 6, 2, 6, and P prime has coordinates, let me see, -1, 7. Okay, so 2 plus -1 is 1. 1 upon 2 is the x coordinate of the midpoint. Okay, let me call this, so let's call that C1, let's call this C2. 2 plus -1 is 1, 1 upon 2, that's 0.5, and 6 plus 7 is 13, 13 upon 2 is 6.5, so 13 upon 2 is 6.5. Let's write them down in decimals, so 0.5 and 6.5. Okay, so let's mark that over here. 0.5 and 6.5 is going to be somewhere over here. Okay, let me make an X over here. Now again, from this point, I'm going to rotate either P or P prime. Again, like I said, it doesn't matter. 90 degree clockwise or 90 degree anti-clockwise. So basically we have one point, we just want another point which we can get by doing whatever I just mentioned earlier. So from the center, if I look at this point P, I can see that this is half and 1 unit to the right and half unit down. Now let's say I rotate this 90 degree clockwise. So like I said, this is 1.5 units to the right and half unit down. Now let's say if I rotate this 90 degree clockwise, so this is going to be 1.5 units down and half unit left. So that means where are we now? We are at 0.5. So what we now have is again 2 points which I'm going to join and extend. And what do we have now? We have ourselves a point of intersection, and this point of intersection is basically what? This point of intersection is our center. So that means what we have done now is we have finally found our center, which has coordinates 1, 8. And there you go. That is your answer. So I want you to have a look at this video again and again. Okay. till you totally get the hang of this. I will try and do more examples. In fact, when we're doing past paper questions, I will for sure be doing more examples, okay? But this is how it's done. To give you a quick summary, so you take 2 points, okay, object and image, you draw their perpendicular bisector. How? By first finding out their midpoint, and step 2, you rotate either the object or the image 90-degree clockwise or anti-clockwise. And you do the exact same thing for another set of points, okay? And then once you've done that, you should have 2 perpendicular bisectors that are intersecting at a certain point, and that point of intersection, fellas, is your center of rotation. Okay, now here we have another example of 180 degrees. So again, it says describe the single transformation with that maps triangle A onto triangle B. Now here we know that this is rotation, so we can write that. And we also know that this is 180 degrees. Why? Because a horizontal line has remained horizontal, a vertical line has remained vertical. Now with 180 degrees, as you know, we don't need to write down the direction because it really doesn't matter. And as far as finding the center of rotation of 180 degree goes, that is the easiest thing there is. You just join the object and the image, and you will have yourself a point of intersection, which will be your center of rotation, which in this case is 0, 2. Is it? Yeah, 0, 2. So what did I just do? I joined A and A prime, okay, which basically means an object and the image. Step 1. Step 2 is that you join B and B prime, which again means the object and the image. Step 3 is the point of intersection is the center of rotation. There you go. And if you're wondering what would have happened if I had joined the other set of points, well, there you go. Don't need to wonder anymore. This is what would have happened. Okay, so I hope this concept is clear. This is perhaps one of the most difficult concepts of rotation, and probably one of the concepts that students struggle with the most. So yeah, keep practicing, and I'll see you guys in the next video with some more example questions. So until then, take care. Bye-bye.